Do them the other way. Calculator. So have your calculators out so you can help me out here in a minute. First thing, HO and HA. On the quiz, just like the last test, I broke it up on this quiz for you. The last one I didn't do it, but this one I broke it up, part A, part B, part C, so you gotta do each thing. On this one, HO, what's the HO this time? Or HA, whichever one. You wanna tell me first? What was their claim?
Mean 1 equals mean 2.
Is that the, that's the HO?
Yeah.
Yes.
Is that the claim?
Yes.
And what's the HA?
Mean
Mean 1 is
1
not
is not
equal to
equal.
mean 2.
Left tailed, right tailed, or two tailed? Get out the chart. We're gonna need the T chart, right? And for the T chart, we need our alpha, which this time was 0.10, and we need our DN. They told us to assume that the variances are not equal. So if the variances are not equal, how do we find our degrees of freedom?
It's the lowest one minus 1. Yeah.
The lowest one minus 1, right? So what is the lowest this time? 11?
7.
7? So 7 minus 1, what's that?
6.
I don't remember which one I put on the quiz, but if the variances are equal, what do we do to find the DF?
N1 plus N2 and then minus 2.
Add them together, then subtract 2. Somebody help us out and look up what's our critical values if we're on the T chart. 0.10, two-tailed for 6.
1.943.
943.
Yeah.
And then the other one has to be negative 1.943. Everybody agree with that
Sir.
on the chart? Then we gotta find our T. You guys said we're gonna use the calculator, right?
Yeah.
So what do you go to on your calculator? Stat, test, 2-sample t-test, and then you put in the numbers there in the chart, right? Phoenix. Put it on my desk. What is it?
1.896, I think.
Anybody else get that? 1.896?
What's the pool again? I forget.
Pooled is whether they were combined or not. So whether we said, are they equal? If they're equal, then it's pooled. If they're not equal, then it's not pooled.
Okay.
They tell you. They're always gonna tell you if the variances are equal or not equal. Is that what we got then, is 1.896? Yes? What do we do with that?
See where it's at.
See where it's at? Where does it fall at? White or shaded? White, so what's that tell us?
Oh, it's right here.
Once we fail to reject the HO, next thing is to write out our interpretation. First part with 10% level of significance. Then we need the chart. There is, the claim was the HO.
There is not enough evidence to reject the claim.
evidence to reject the claim that what claim?
That the mean annual cost, of routine veterinarian visits for dogs and cats are the same.
Is that gonna bother you that I went downhill there, Mackenzie? Is it? Good, that's what, put here on our, just to bother teenagers. Other questions? Everybody can handle all that?
We don't need to go through it, but for 19, the HO and HA, and figure out the claim, since it's asking like a question of, does the treatment make a difference, does that make like, equal, and then is that the claim?
Yeah.
Okay.
No, the claim is that they're not equal to each other, so the HO would be mu1 equals mu2, HA would be mu1 doesn't equal mu2, that's the claim. Yeah, because I know when I did that problem, because you'd think, when I started it off, I thought, all right, if I'm making up this new thing to test the tensile strength of a metal,
We'd want it to be better.
you want it to be better, so, but that's not the way that they worded it, so they're not saying, their claim isn't that it's gonna be better, it could be worse.
Except there's a difference.
They're just saying, hey, this is gonna make a difference, well,
It could be positive or negative.
right. I guess I could make up something that completely destroys the metal and say, oh yeah, the tensile strength is gonna be different. You know, use this acid on it, and it'll be completely different, it'll be ate away, but I don't know what good that is really, because you want the tensile strength to get better, not just one or the other. And on 19, what we do today, you're gonna have to put them in list in your calculator. Several of them are, I shouldn't say you have to. They're probably gonna make things easier if you put them in list. So on 19, that one you had to put in list. Are we ready then?
There should be like a +5.
You didn't give me a second to answer, because I had to say thank you to Caden. I was gonna say, sucking up is always appreciated, but it doesn't help your grade. What I will do on this, if you can do it quickly and quietly, you can work with a partner. That's the title here. A little harder today. I know I said that last time too, but continue to progress and be a little tougher.
So when's the easy stuff out?
About June 5th.
When you graduate.
Flipping those boogers.
I never understood how to do that in geometry.
Just set up proportions.
Could never do it.
I want, I don't know for sure because I don't remember back that far, but I would almost bet that if I asked around the room why Joe didn't understand that stuff in geometry, about 3/4 of the people in here would say, I bet he was absent for a long time during that time. I bet he missed a bunch of days during that time. Probably.
How far back do you remember?
I never got
Yes,
that. I always got.
Don't worry, Sean, when you're out of here for a year or two and you come back for some reason, or I see you out somewhere, it'll be like this. Hey, how you doing? Hey, it's good seeing you again. I won't have a clue who you are. I'm sure I told you that in geometry too, but some of the few people that I do, like Jordan, I'll remember Jordan.
I hope so.
That's just because I'm related to him, and no other reason.
I'm gonna do something huge so you can't forget me.
I'm sorry, but.
Shoot,
I
that
had-
sounds, oh.
What about V. Carey? You have his
I-
senior poster.
I had a student my first or second year of teaching. He,
So you remember this kid?
listen to what I'm getting ready to say. He, all in one day, robbed 3 convenience stores, shot 2 people, kidnapped the lady that was working in the 3rd convenience store, and went to jail for life. I have no idea what that young man's name was still.
I didn't do anything that big, so. I
You
guess you're
gave
gonna
us-
forget me.
So-
Three
probably-
in one day?
it's probably not
Yeah,
gonna
that's
happen.
weird.
Probably like,
Okay,
you
we
would
go
do
for
something
one
like
night on
National
that.
Days, dude.
Leave Gage's poster up. I hope he was
Yeah.
playing felony bingo. Trying to get all
You want to hear the crazy thing? His brother, who I also had in class, I don't remember his name either. His brother qualified for the Olympics in high hurdles, worked as an intern at, first he went to West Point. Worked as an intern at the White House for like 2 years. And he did something else after that I can't.
Couldn't get his brother apart.
Can you pardon my brother? He only
But-
shot two
He
people.
only shot 2 He's a good guy,
Robbed
so-
3 stores,
He
he
pardoned.
kidnapped a lady at the last store.
They were brothers, and it just took him. I never knew that they were brothers till I met their dad. And he goes, "Oh yeah, you had my other son."
Hey, he's in jail
He's
now.
probably so well mannered, instead of like free money.
You probably stopped seeing him halfway through the year.
You know, can we pardon my brother?
Well,
Let my brother out.
he threatened that he was gonna beat me up at a baseball game one time because he came to a baseball game and I think he was a little high or drunk or something, and probably. And I said, you know what? I think you need to leave. And he's a big fella too. There's nobody. I can't think of anybody here that you can compare him to because he was probably about Aiden. He was taller than Aiden. He's probably about his weight.
Terrifying.
Yeah. So he's a big fella. And so and when he said, he got mad at me because I was telling him to get out, and I was a little worried.
It was so easy for him to commit that many crimes in one day, bro. We probably shot him and didn't stop him.
You always gave him like a 10% bump on his test.
He didn't pass anything. I don't think
10% of 0 is
he did. The guy that he was with at that baseball game, I really liked him. Him I remember. Chauncey, his name was Chauncey.
What did he do?
He was just
Chauncey?
Chauncey.
He was just nice.
Chauncey?
He was a really good guy.
I know like remembers the name.
He was always nice to me. All right.
So I'm just gonna be nice to you for the rest of the year.
So,
You remember.
so the one thing I always remember about Chauncey is I used to take kids home all the time, and I took this kid home at Whitney Young. not to my house.
So you got that on recording, Ebersole.
took this kid home to Whitney Young, and it was, I don't remember, he must have played baseball or something. We must have practice on a day off, on like a holiday or something. Because all these people at Whitney Young Whitney Young is a housing complex, nothing like you guys ever think of around here. All right, it's a housing complex that is not a good area. It's not as bad as DeSoto Bass, which is in the middle of Dayton, but it's awful, you know, it's not the greatest. And I pulled in there, parked, and got out to help the kid get his baseball stuff out of the back and stuff, and all of a sudden there's about 50 people walking towards me. Because I was not the right complexion to be in that area. And Chauncey happened to live there also, and he came running over. Hey, Mr. Ebersole, how you doing and stuff, and started telling everybody, you know, to leave me alone. Now Chauncey, he's probably long since dead because last time I seen him, well, that wasn't the last time. One of the last times I seen him, he dropped out of school and he was standing on the corner there at Whitney Young, and I think I was going to UD or somewhere. And I went by there and I seen him standing there, it was pouring down rain. And he's just standing on the corner. So I turned around and went back. I said, Chauncey, what are you doing standing out here? Nothing. I'm not doing anything. He was selling. And I said, Chauncey, I know what you're doing. Get your butt in out of this stuff and quit being stupid. Like a month before that, I'd seen him, and he was limping real bad because he'd gotten shot when he was doing some other deal. I said, Chauncey, you just got shot. It's not a month to get shot. And you're out here doing this stupid stuff again. But he was.
Mr. Robbie.
You're better than me.
So testing. What we're gonna test, the difference between the means. Now this is gonna be, it's a little different than all the other stuff that we've done. So now instead of saying mean 1 equals mean 2, now we're gonna say mean 1 doesn't equal mean 2. That we're trying to see if they are different and how much different they are. And this time it's gotta be dependent samples. So this is gonna be the one where, like, we take your heart rate when you're just sitting here doing nothing, or we take your heart rate after you ran a mile, and we compare the two, all right? So when we're doing dependence, they've got to be paired up. Everything in sample 1 has to match up to something in sample 2. So that's what makes them dependent. They have to match up. If they don't match up, then we can't do this stuff. So they have to match up. 3 in the first one, 3 in the second.
Oh, there's patterns.
Like, no, the amount of the end. So like.
Are you saying the difference between?
So like, the
Here.
one that we just did.
I wasn't here the
and
first
one
day we
is
learned
6.
this.
Hold
The
on.
other one had like 5 on this side and 3 on this side.
That has 5 and 8.
So here, Michael, here you go.
Say 5 numbers.
The N in this one, how many there are in the sample, has to equal
Okay.
the N in that sample.
That makes more sense than 5 and 3.
Ben tried to say it 7 times, and
And Ben's like 5 and 3 and 1. What? That's a 5 and an 8. What's it?
so they have to be dependent, they have to match up, they have to be paired. Let's see on this. Form 2 sample data and dependent samples, difference between them. I would write this down. Got to be able to find the differences. Most of the stuff that we do, it's not real hard to find the differences. You're just subtracting this one minus this one. Not difficult to do. So to do these tests, to see if there is a difference between the means in the 2 samples, First thing you're gonna do is find the differences. Then you gotta do this. And I would write this down. This is your test statistic. Now, that's not, and I didn't realize this, I didn't tell you guys this last time. The test statistic is just the top of your standardized test statistic. All right, so this is what's going to go on top of the fraction. This is called D bar. D bar is just like X bar. It's the average or the mean, I shouldn't say average, it's the mean of all the differences. So you add up all the differences and divide by how many of them there are. And as we go through this, it'll make more sense. It's not really all that hard, it's just a little more complicated. And again, you can use your calculators on it, and I'm going to show you how to use your calculators on it. And I'm also going to show you how to do it out longhand, just because I don't know that one way is any easier than the other way. It just depends on the numbers. And it depends on how much you like typing lists into your calculators. So we got to find D. Once we find all those differences, we're going to add them all up, divide by n. That's going to give us D bar. Sorry, thought there was another part on this slide. All right, Lily, I'm gonna give you a job. Flip through the pages, all right? Just flip through it so I can look at this and see when we go to the next one on the next slide, so I can see, okay, this is what I want to say. Just make sure I'm telling you. On this, same idea as all the other ones. The sample's got to be randomly selected. Samples, except, I shouldn't say the same thing, because there's one main difference. They got to be dependent this time, and both populations have to be normally distributed. What this is, when we're doing all this, and I've said this in the past, what you're actually finding here, we did that one part in one of the chapters where we found the mean of the means. That's what we're doing here. We're saying if we take enough samples and do it over and over and over again, then the mean of all those means is going to be normally distributed. All right? So if we were to do it millions and millions of times, it would come out to be a perfect normal curve like that. And if that's the case, if we get a mean that falls out here somewhere, then that's unlikely to happen. So something's not right. Degrees of freedom. Degrees of freedom is just n minus 1. That's not too difficult because in this case, both the n's have to be the same. You don't have to worry about n1 and n2 because they got to be the same. Otherwise, they won't be dependent. They won't be matched up. So when you go to find your degrees of freedom, it's just n minus 1, whatever n happens to be for both samples.
Ellipse. According to your shapes paper.
Ellipse, not
Ellipse.
ellipse.
I like ellipse. It's an eclipse. That's what I'm doing.
The number of pairs of data is n. I don't know that I'd write any of this down. This is just telling you what each one is. MD. We're going to use that instead of mu1 and mu2 like we've been using. MD is gonna go in our HO and our HA. Again, D is just the differences, where you match them up. All right, this was Mackenzie's resting heart rate. This was Mackenzie's heart rate after running a mile, whatever. You match them up, and you do it for each pair. Again, D-bar, we just did that. D-bar is you add up all the differences and divide by how many of them there are. SD, that's the standard deviation of the differences. Wait to write that down because I think on the next slide, let me look real quick. Yep. There. That's how you find your standard deviation of the sample. What's this crazy looking east mean again? So that means you add up all the D squareds, you square each difference, you add them all up here, you add up all the D's, then you square that answer. Not a real hard formula. Once we make the chart, it's pretty easy to plug into it. Formula to find your T is going to be, this goes on bottom, and on top was, yeah, I think it's on the next slide too. I'll just do that. So that's your test statistic. Your standardized test statistic is this. So T equals, I'm going to rewrite this, D bar minus mu D over SD divided by the square root of N. That SD is that big formula. I probably should do that, see if I put it on here. Nope. So that's your formula. Get rid of that so you can see that. Couple of things I'll say with this formula. Anybody have a guess what mu D is going to be? 0. All right, so that just sort of going to be gone every time. And all it's going to be on top is that D bar. The SD, that's the formula that you just wrote down from the last slide. Again, there is a way to do this on the calculator. It'll find T for you, but that's all it'll do. It'll find T. You still got to do all the other stuff, the HO, the HA, everything yourself. Thing that worries me about that, but you don't think that means standard deviation?
No, because I have it right
The T chart? Yeah. Anytime you're finding T, you're still using the T chart, not the Z chart. Degrees of freedom, again, just n minus 1, both ends are the same, so it doesn't matter which one you take. Give you a second, you might want to draw this chart. This is what the chart needs to look like. I actually ran off some charts that I'm going to pass out to you, but I won't always do that. This is the parts that you're going to need in the chart. You need your sample, your first sample, sample 1, sample 2, the differences, and then the differences squared, I'm not even gonna write that over there, is that all right? I'll abbreviate, differences, each one of those squared. And then down at the bottom of the last two columns, you add all those up, and that's, we're gonna use that to plug into our standard deviation formula. Now I got like, what, 4 lines there, it could be, 7 lines, 12 lines, 15 lines. Hopefully not, Riley, hopefully most of them are, they'll stay around 7 or 8. And again, at the top I have, you can put it in list, so you can put sample 1, all the stuff from sample 1 here, in one list, all the stuff from sample 2 in a second list. And I'll show you how to do that. The second step. You know how I've made those lists for you every time? This is the list, just separated out this time. When you state the HO and HA, this is where it's different, so you might want to make sure you pay close attention to this. Ah, man, I messed it all up. Heck on it. Your HO, I forgot something here, is going to either look like this, or HO is this, or HO, can't believe I messed that up. I came in here on Saturday just to redo this so I wouldn't have it all messed up. So your HO is going to say MD, the mean of all the differences, is less than or equal to 0, or MD is greater than or equal to 0, or MD is equal to 0. That confused the crap out of everybody since I had
Is
it
it
wrong.
UD or M?
M sub D. D.
So M? Is it
Oh,
mu?
mu, sorry.
That's the part that was confusing me. We got a new symbol?
No. My
Looks
fault.
exactly like you.
The last class, who was it? Riley or somebody somebody was making M's.
That was Daniel.
Was that Daniel?
They're basically M's. It's close enough.
And I'm like, it looked like an M, but it looks like it's moves.
Make sure the next step, make sure you tell which is the claim. Then these next few steps all go together. You're going to draw your little picture. Decide, that's pretty bad. Decide whether it's left-tailed, right-tailed, or two-tailed. Same as before. Now when you decide, if it's left-tailed, right-tailed, or two-tailed, the next thing you're going to do then is use your alpha and your DF to find your critical value and draw it. So this would be like step 3, 4, and 5 on everything else we've done. You draw your little thing and you decide if it's left-tailed, right-tailed, or two-tailed, and you go to the T-chart, and you find your critical value. Remember your DF, unlike the last section, the ends are both the same, so you just gotta pick one of them and say whatever n is minus one, and then use that on the chart. Again, Brian asked this earlier, yes, you're using the T-chart again. Hopefully, we don't have to find out if you could use the Z-chart if there's 30 items, because then it starts to get very, very tedious and not a whole lot of fun. What do you gotta do once you draw that? What's the next thing?
Find D-bar.
Alright, so you're gonna find D-bar, then you're gonna find your SD, then those two things are gonna lead you to find what T equals. I don't know if I got that written down anywhere, but the formula, you want me to write it this way, out longhand here. On top, it's gonna be sum of D divided by N minus mu D, which is always gonna be 0, over that whole thing there. Sum of D squared minus sum of D squared divided by N, all that over N minus 1, just a little smaller. Then all of that is over the square root of N. So it looks real complicated and hard, but once you stick in these numbers, just as you go through and do it, you just gotta do one part at a time. Usually the numbers aren't that difficult. That's that formula to find T. I'm not gonna rewrite it again, we just rewrote it a minute ago. So you got D bar minus mu D on top, which that's always gonna be 0. Find your standard deviation, which is this big long formula. Find your square root of N, divide those two, then whatever the top is divided by all of that. Looks a whole lot more confusing than it actually is hard. Next thing, decide to reject or fail to reject the null. Here, I was yelling at you guys and I forgot to write null in there. So decide whether to reject or fail to reject the null. Then what's the last step? Interpret. Interpret. Go through this real quick. This is just a list. I just separated it there so I could say more stuff about it. Drawing the graph, doing all that stuff, finding the T. Decide to reject or fail to reject, interpret it, so on and so on. So we're going to do this example together. I'll show you how to do it. We'll do this example both ways. We'll do it using your calculator. First we'll do it.
Yeah, we didn't.
First, we'll do it using a list, then using the calculator. A golf club manufacturer claims that golfers can lower their scores by using the manufacturer's newly designed golf clubs. 8 golfers are randomly selected, and each is asked to give his or her most recent score. After using the new clubs for 1 month, the golfers are again asked to give their most recent score. The scores for each golfer are shown in the table. Assuming the golf scores are normally distributed, is there enough evidence to support the manufacturer's claim? So the first thing we're going to do, we're going to write our HO and our HA. I'm going to come out here to the side and do this. HO, and this is a little different than on the others. HA, what are they saying here?
subtracted, this is close, it'll be better.
Alright, so what should happen to the scores?
They should go down.
They should go down. Now, so when we do this, again, it's gonna be MD, mu D, sorry, mu D, alright? What is the manufacturer claiming?
The loose golf clubs can lower your score.
So what should be true about your old score?
It should be.
It should be bigger than your new score, right? So they're saying that mu D is greater than what? 0. Remember, mu D is the difference in the two scores. So we're saying when you subtract these two, what should happen? Like, let's look at this first golfer. Did they get better? Yeah. So when we subtract them, what do you get? Positive 6. So when we write this out, you got to be careful, because especially with golf. Golf is a terrible one to use here because the actual lower score is better, a negative score is better than a positive score, and it's just sort of backwards, right? So when this goes down, did the manufacturer's claim work? Yeah. So this is your claim. 1 second, and then this one's going to be greater than. This one's going to be less than or equal to 0. Yes. Yes. Sure. They want you in the office, man. So we have that. Next thing we're going to do. We're going to draw our little thing here, a little graph. We left-tailed, right-tailed, or two-tailed? Right-tailed. So draw that, shade that in. We got to find our DF and our alpha. Our alpha was what, 10%? DF, how are we going to find our DF? N minus 1. What is N this time? 8, right? How many golfers are in each set? 8. So what's 8 minus 1? So now get out your little chart. We want to look up 7, 10%.
1.415.
Yeah.
Everybody agree with that? Yes, no, maybe?
Yep.
Now, the next thing we need to do is we need to find our T. But before we can find our T, and this is where I got to go on to something else here. Before we can find our T, we got to make this chart. And it's not hard to make this chart. So as I'm looking at this, all we're going to do, this is our first sample, this is our second sample. We're just going to subtract these. What's 89 minus 83? So 6 goes there. 84 minus 83? 96 minus 92? 82 minus 84? Negative 2? Negative 2 again? 1, 5, 0. Then to finish out the chart, well, we're going to have to do something down here, but finish out this, all you do is you take each of those numbers and you square them. What's 6 squared? 1 squared? 4 squared? Negative 2 squared? Positive 4, negative 2 squared? 1 squared? 25, 0 squared? 0. Grab your calculators for me. We want the sum of that one and we want the sum of this one. Some of you do the first set, some of you do the second one.
The D squared is
411?
That's what I got. 411.
400.
I got 87.
Oh, I did 361.
I was do it.
I got 87.
87?
16 plus 2, 4.
This one's 13.
411.
Everybody agree with those two?
Yeah, plus 5.
13 and 87?
Yeah.
Alright? Now the formula.
361 plus.
On the formula, on top, it says it wants the average of all the differences. So we got 13 here. What do we divide that by? How many of them were there?
8.
8. Somebody help me out and do 13 divided by 8.
1.625.
That's what's on top. That whole equation, that's what's on top, all right? Then to find our SD, our standard deviations of the differences. Somebody tell me, make sure I'm not doing this formula wrong when I do it. I think it says, what, sum of what? What's it give first on that formula for SD?
Sum of D squared.
D squared?
Yeah.
So sum of the D's squared, that, so what was that?
87.
87 minus, then it's sum of all the D's in parentheses squared, right? So that'd be 13 squared divided by n, which is 8, right? Remember, n is 8, df is 7.
Divided by 8 minus.
Divided by 8 minus 1, what is 8 minus 1? So you see this formula, it looks hard, but it's not really all that much to it. Somebody type all this top into your calculator. What's 87 minus 13 squared divided by 8?
1.7.
And once you have that answer, divide it by 7. Now this is where I mean, it's not easy, it's not hard really, but you got that answer on your calculator. Now what you gotta do is you gotta hit second, then the square root button, and type whatever answer you just got, type it into there. And I would go out 4, 5, 6 places, however many you can go out. It's right there on your calculator, hopefully, so. Anybody get a final answer there?
3.4715.
Is that-
0.067.
Huh?
I got 0.67.
Yeah, I got 0.67 too.
0.67.
3.067.
3.067?
Yeah,
Is that what we're going with?
that's what I got.
Yeah.
Huh?
I got what I got.
So try it again. Let's,
So 87 minus.
13 squared divided by 8, hit equals.
That's what I did wrong.
And then now you got that answer on there. Then hit divided by 7, hit equals. And then that answer's right there on your calculator. Now hit second square root and type that back in there. 3.067. So that's on bottom here, 3.067, except we still gotta remember to divide that by the square root of n, what was n?
What did
8.
y'all round off to?
8. They went out 3 places.
I just used the whole number.
That's why, I mean, that's what they should have been.
I used the whole number, okay.
I used the whole number and got people.
You're doing your math wrong then.
Boom. So when I do this, I'll tell you this on the calculator, when I do this, I type in 1.625, then I put a hit divided by, then put a parenthesis, then I do this, and at the end you have to put 2 parentheses. So it'll do it right, so your calculator doesn't get confused. And what'd you come up with, Jackie?
No, I just did the bottom part.
Oh, okay. Anybody get the whole thing there, what T is?
1.498.
Anybody else get that?
Yeah.
It's a little tougher to find T, it's just, it's not hard, you just gotta be careful because a lot of places that you can mess up. What do we do once we have what T is?
See if it's in the rejection.
Is it in the rejection region?
Yes.
So what's that tell us?
Reject.
Reject the null.
And then interpret.
If we reject the null,
Okay, I got it.
did you get it that time? we reject the null,
Isn't that 3 times? I got it right last time. Good job.
we go back up here, and we're gonna say with a 10% level of significance, there is, now we use the chart, we reject the null, and the HA was the claim. What's the rest of it say? There is what? Enough evidence to reject the claim? I think Brendan's guessing, so I don't know.
I'm pretty sure it's support the claim if we're rejecting the null. I mean, it's the.
Oh, yeah, you're right. See, I didn't even know about back here.
There's enough
To that
evidence to
page.
support the.
There's enough evidence to support the claim, and then we'd say, there's enough evidence to support the claim that what?
These golf clubs will give you a better score.
These golf clubs will give you a better score. I don't
This
see
isn't
it.
golf club.
Always
Wait,
true.
yeah, I was about to
That's
say
true.
that's false.
I don't think that
Because better does mean better. in
I don't
golf.
think that sounds right, though. I thought when I did it, that
Better means better.
you got the other way.
More money
Let's
means
see.
better scores.
Let's see what this is. So we got that, we got that.
Golf
EF was 7, that wasn't hard. That's what we said over there, right?
Mulligan, man.
We did the chart.
Score on my card knows it's something different.
Is that what we got? 3.0677, something like that?
Yeah, the one Phoenix said was wrong.
There, he's just gonna keep hammering you.
I got it right last time. I'm just happy I got it right. He said he didn't.
Reject the null.
I got it right.
Yeah, 3.
So,
Seven.
so test, results of the test indicate that after the golfers used new clubs, their scores were significantly lower.
They weren't significant.
Yeah, it didn't look like it was a whole lot to me.
How much were they close to?
Yeah, how much are these supposed to act?
Like, what's the price?
All right, you might wanna write this down. I'll give you a second to write this down. This is how you do it on the calculator. I don't like using the calculator on these, but in my old age, I might start using the calculator because I'm getting lazy and don't feel like writing anything down. Yeah, you could also put Phoenix in there, it means the same thing. Confused.
Like zoning out over here.
Once everybody gets this done, get your calculators out. We're gonna put those numbers into the list so I can show you on your calculator how to do them real quick.
Hey, man, you gotta stand up.
So first thing you gotta do, you gotta put each of them in a list on the calculator, list 1, list 2. I think most of the calculators got, what, 6 or 8 lists, is that what they have on them? Something like that, so you can.
Mine has 26.
Yours has 26. See, I don't know, the TIs, they might have more than that, I've just never
Mine
tried
has
it.
11.
Is it? Once you put them all in, this is where it's gonna be different. Has everybody pretty much got it down? Where are you at, Maddie?
The last thing.
All right, go back. It's gonna be a pain in the butt because it's gonna have to do it one at a time. Type these. Type this into list 1, this into list 2, or 2 consecutive lists. I don't care which 2 really. I'll give you a minute or so to do that.
You know, like what we doing all
Yep,
year?
yep, yep.
Yeah. Alright, glad to hear it.
You have to help him out, Michael. He gets lost every now and then. He's playing one of those games on his phone back there. It takes Ebersole doesn't know you're doing it because he's hiding it behind your mic.
I'm gonna go to your church.
So help him out.
I will do.
That's wicked.
We're sitting up there.
Cause he wasn't like.
I know who it was.
Now I'm going back and just put the phone away, dude.
Do we have them in the list? Let me know when everybody gets them in the list.
I got mine on the side.
I got mine in the
You're good, man.
Sounds like top 5.
You're good, baby.
I'm top 50%. I might be, I don't know.
See, I wasn't gonna say anything.
See, I don't know, cause I had a bad run
Like
off
top
the year.
second.
I could have said something smart like, I don't know, that's pushing it or something like that, but I didn't.
Phoenix, just ask for your, email Williamson, ask for your transcript.
And we got it? This is where it's different. On your calculator, if you put it in list 1, list 2, go to list 3, make sure everything's cleared out of list 3. All right, so make sure that whole list is deleted and go to the title. So where it says L3 or whatever it says on your calculator at the top, go in there and hit the up arrow and it'll go up here and it'll highlight this. All right, now what I want you to do is I want you to type in L1 minus L2.
That's pretty cool.
And then what it does for you, it does all the subtracting for you.
But then how does it, can it do with D squared?
It's like a spreadsheet. Oh my
I
gosh, guys,
guess
I've never done this before.
L3 squared.
Now, we really don't
Girl,
need,
what is she doing?
listen closely, we really don't need the D2, the D squareds, if we're gonna let the calculator do the work for us. All right? But what you could do is go to list 4, do the same thing. Go up, highlight it, and when you get up here and you're highlighted on it, just take L3, type in L3, oops, not L3, that way, L3, and square it. And it'll give you this
Did
list.
you do nothing in, what's his name, Wendell's class?
No.
It's just a spreadsheet, dude.
Yeah, I did something Windows class. No, I cheated off Nick the entire time.
Now, we really don't need that list, so if you're doing the problems, you really don't need that D squared, because the calculator is gonna do all that in the stuff. All you do next, and I'm gonna go try to get back to our other slide here. All you're gonna do next, go to Stat, Test, and go to T-Test. That T-Test is what we did, not the 2 T-Test, just T-Test. That's what we did last chapter. And then once you get to that, go highlight data this time instead of stats. We don't want stats this time, we want data. Highlight data, and then this is where you gotta make sure, because some of the calculators have other stuff in them. Your mu sub 0 has to be 0.
HA was.
Your list is the list of the differences, so whatever you put that differences in, mine was L3. Type that in there. Your frequency has to be 1. So a lot of times the calculator will change the frequency. It'll have like 0 or 3 or 7 or something else there. Make sure it's 1. Your mu, whatever the HA is, the HA this time was greater than, right?
Yeah.
So we want the greater than. You hit calculate.
We got T.
Was it bold or was it not bold?
What? What do you put us against 2? L2?
Yeah, see,
You don't want L2 there, you just want L3.
You just want the differences.
So what do you put?
Whichever one,
L3?
L3 for both?
this is all we're gonna look at. It's gonna tell you the T. I'm not sure why my statistic is down a line, but that's supposed to be up here.
It's the ghost.
It also tells you P. We're not doing, that's the P-value stuff that we did start last chapter, we're not doing it. It tells you X bar, which is actually D bar, and it tells you the standard deviation, which is the standard deviation of the differences.
Hey, Mr. Ebersole, what do we put as list 1 or 2?
Well, it should only be one.
There's 2
Well, because
lists.
I got list 1 and list 2.
Are you on data?
We went
Hey,
to-
we're stupid, just stop talking.
Okay, never mind, we're good. Yeah.
Yeah.
Wait,
What I said.
Yeah, it's just T-test.
Did they go to the wrong one?
No.
No, we're good.
We're good, we know what we're doing.
Did
I
you
really
put
asked you guys
everything in
if you
one
wanted to.
list?
Yes, totally.
No,
Yeah.
they went to,
No,
they
no,
went to
no,
the
no,
two
no.
sample T-test, even though I said, make sure you don't go to
There was a
two
ghost
sample.
Ebersole, okay? It was a long story, and there was a ghost. Just touching Benjamin. Weird
Yeah, I'm
ways.
only doing it on calculator.
Hey, I'm dying.
It just
I
didn't see
forgot which one was the
Wait, what if I got different numbers?
That one was
You did it wrong.
I think I got different numbers.
That's why you asked is it pooled and no one answered.
Yeah, I was confused.
That's your assignment, laying on this desk right here behind Lily. If you like doing the list, there's some papers there, grab 3 or 4 of them or something for the list.
I don't think I wrote it down.
So you're not gonna use the dang
Are you
list?
gonna use the calculator?
I'm gonna use the dang calculator. No, the dang calculator is a lot easier.
The dang list is more for you to write, because you know that you're not gonna do it.
Because the dang, what is it, the dang,
Dang, Michael.
Frequency, just put one, don't put list one.
Well, that was there to start.
Yeah, see, that's why I said that.
Michael, if you were in this class,
A lot of times, the calculator, for some reason on that, took a frequency, it was 3, 5, something. I don't know where that comes from, but she's Sean.
That's the good part, is that if you're truly naive, if